Good evening friends. This is a small video on how to plot charts or diagrams or graphs on Smith chart. The subject is microwave and radar engineering. The topic name is impedance matching, and the first subtopic under impedance matching is L section impedance matching. For this we use ZY chart. What does a ZY chart means? You can see here is a dark line that's known as z equals to 1 circle, and the dotted line you can see is this dotted line is g equals to 1 circle. So we if I make it a bit zoomer, you can see this dotted line indicates susceptance, at the same time this dark line indicates the reactance. So steps to solve this L section impedance? Let's go with an example. The example is design L section matching network, and we have given the load impedance as 10 plus J10 and the characteristic impedance as 50, and it is operated at 500 megahertz. How to solve? Always remember, you do any Smith chart problem, you first need to make it normalize. You normalize it so that the value can be collaborated or be plotted on the Smith chart. As we know, we have minimum values. The maximum value on the Smith chart we can plot is up to 50. You can see the real part is 50. So I first normalized the value as 0.2 plus J.2. So I took my pencil and then I plotted 0.2 plus, this is my 0.2 and this is my impedance. You can see you need to see the upper side, impedance 0.2. I marked it first. You can see here I marked it. This is a point I marked. You can see here I have written B alphabet. If it is pencil, so I just rewrite it again. It's B. I will tell you why it is B. Now for solving this L section, we need just to remember these formulas. Whenever we travel on dark line, we are always in series. Whenever we travel on dotted line, we are in parallel. And always remember, for series, in the formula for inductor is J omega L, and when the inductor is in parallel, it means it is 1 by J omega L. Capacitance, if it is series, 1 by J omega C, and for parallel it is J omega C. So the formulas given are like this. For J omega L, X denotes as susceptance, A and B I just marked. I will tell you exactly how to calculate A and B. J omega L as XA minus XB into Z0, 1 by J omega L if it is parallel, and susceptance minus at point A minus point B is into Y0. In J omega C, sorry, by mistake I have written the wrong formulas for J omega C. The correct formula you can note it down here. The J omega C is susceptance at point A minus susceptance at point B into Y0, and 1 by J omega C is reacted at point A minus reacted at point B into Z0. Now how to remember this? Always remember this table. Whenever you have series, we have J omega L and 1 by J omega C. We use reactance. You can see here we use reactance. And when it is in parallel, 1 by J omega L and J omega C, we use susceptance and admittance. Susceptance and admittance, susceptance and admittance. And whenever we travel in upper direction, it's always inductor, and whenever we travel in downward direction, it's capacitor. Let's solve this up. I would request, before solving this sum, you please note down in a piece of paper, as I'm keeping with me next to me here. Now I have first plotted my point, the normalized load impedance. Then it comes in dark line. So what I've written for a dark line, it's in series, and in C I am going upward. So for upward, it is inductor. So I need to first find, go till the value it intersects the unit circle. I repeat, the dotted unit circle here. As you reach at this point, and now it is series inductor, we need reactance at point this and this. We are moving in this direction, so the upward point will be A. The upward point will be A, and the lower point will be B, and we are traveling in this direction. So how to write is I need to calculate the reactance at point A. The reactance at point A I got is 0.4. I'll show you how I got it. The upper value is my reactance, so it is 0.4 minus 0.2, and it's in series, so it's inductor. So I'll be using the formula for series inductor. So the formula is j omega L 0.4 minus 0.2 into Z0. I have taken j common here, cancelled j and replaced omega by 2 pi f, and I know the value of f. Once I get that, I get the value of L as 3.18 nanohenry. Always remember, inductor should be nanohenry and capacitor should be in picofarad. Now how to remember that if this gets negative? Always remember, inductor and capacitor after finding the values won't be negative. So by mistake, if you have taken 0.2 minus j.2, here you will get minus j.2. J will cancel, but still the minus will remain. It means that you have taken the wrong values and you need to reverse that. Now we'll go ahead. We reached till point here. Now this is the dotted line. You can see here, and once you reach there, you need to reach to the center 1. Okay, so I need to travel in this direction. So this is my B dash point. I'm going down here. So this is a substance point. Yeah. Now at this point is 0.4. So 1 minus 0.4. One more thing, I just forgot. It's a dotted line, so it is parallel. Dotted line parallel, and we're moving down, so it's capacitor. Parallel capacitor, J omega C is the formula. So I'll be using susceptance minus susceptance at P. Now as we are traveling downwards, you can see here we're traveling downwards. It is for capacitor and it is dotted line, so it's parallel. So I go it for parallel capacitor, it is j omega c. My formula is j omega c susceptance at point A minus point B into y0. So this is my point A, so let me name it as A dash so it won't get repeated. So I need to do as A dash minus B dash because I am coming here. Susceptance at point here is 0 because it's the real axis, real part is like 1 plus j0 or 1 minus j0, and I need to find the susceptance at this point, so I'll just maximize a bit. So you can see here the value is 2, so it's better from this view. Yeah, so the value is 2 here, and I need to find susceptance at that value. This is reactance, the lower values, and we need to remember susceptance value increases in this direction and reactance increase in this direction. So susceptance here, this is approximately 2.5. So the formula comes as at point A it is 0 minus susceptance is in upper half, so it is minus 2.5, and z0 input, that is 1 by z0. So 2.5 into 1 by 50, that is positive. 1 by 50 is the characteristic impedance into 2 pi into 500 megahertz. The answer comes to be 15.91 picofarad. That's one more method. Why, if instead of going up we can go down till it intersects. So if I get this down here, it will intersect at this point. Let me make it a bit darker. So this is darker line, So series downward one means capacitor. So you can see here series capacitor formula 1 by j omega c. You need to use this. Find the value of reactance. Remember, reactance increases in this direction and susceptance increases in this direction. Towards the left hand side, the susceptance increases. And then this is a dotted line, so it's parallel and we are going upwards. So it is 1 by j omega L. You can see here parallel upwards, dotted is parallel and going upwards inductor. So 1 by j omega L, we need to use the formula, look at the value of reactance and the susceptances we have to use, and thus that gives value of L and C. So this is known as lumped parameters. The value of L at the final record is 3.1 nanohenry and the value of C is 15.91 picofarad. Thank you.